Hello everyone. Let me know if I'm audible. Okay, Rahul. I will start in a minute or two. I'll let few more people join. Okay. So today, basically, like I will be taking two problems. So it is divided into two parts. This is the first stream. It will be from 8 to 9, and the second stream will start from 9:15 and it will go until 10:15. Okay. So I picked two interesting problems. One is like very trivial and very popular problem, like not only asked in Swiggy, in many of the companies, but it has some good follow-ups and variations, so I have picked that problem. Till then, if anyone wants to ask anything, they can. I can wait for like next 1 to 2 minutes, like 1 minute at max. Okay. So firstly, let me start with my introduction. Okay, and then I will like go in and tell you like how will I take the session and how it will lead. Okay. So myself Shashank, and I currently work as a software engineer at Inference Labs. Previously, I was working with ClearText as an SD1, and I interned at Red Hat. I was also the ACM ICPC 2019 regionalist, and I have around like 1+ year teaching experience. And the subjects which I take are DSC in C++ and interview preparation. Now let me come over this career as a developer subscription. So basically, this is for those people who are aspiring to be a software developer or who are already a software developer and in their initial phase. So this can be a very good thing to them. So it involves like the openings about various product-based companies or the service-based companies which are hiring and how to apply to them. There will be talk shows from HRs, like they will be coming and telling their or giving a brief about their hiring procedures and all. Okay. And there will be live problem solving as well, and it includes over the weekend projects as well. And apart from all this, like there is also one talk show where people who have already gone to some good product based companies, they would be coming and sharing their journey as well. Okay, and you get all these things under only like 999 for 1 year, and if you use my code as Pathak 10, then you can get 10% off and you can avail it at 899. Okay, now coming to college project, which I told like it is also a part of that career as a developer subscription. So over the weekend project, which I just discussed in the last slide, so it's taken by Raj Striver, and it takes place every Friday night at 10 p.m. So all those people like who are in the 3rd or 4th year, or even people who are looking for full-time opportunities or internships, so projects always play a major part in that, and this can be a very good opportunity for all of you to learn and take guidance from him. Now comes the Code Chef Apprentice. So it's taken by Sai Avinash. Sai Avinash is currently working as an SD at Google, and he is a 7-star rated programmer at Code Chef. So this takes place every Saturday afternoon at 2 p.m. and it has already started from 14th of August. So basically like in the college time, or like currently what the companies usually ask in their online assessment stuff. So being a competitive programmer helps you a lot, and if you want to upscale yourself in competitive programming, increase your rating and learn how to think over a problem and how to solve a problem, what are the problem solving strategies and all, so you can definitely take this up. And Sai Avinash will be there. He will be taking your queries, and even live problem, he will be also taking the live problem solving stuff, so you can definitely go and check this out. Okay, Do like, share, and subscribe. Do share this stream with your friends so that like anyone who is interested for how an interview goes on and how to solve a problem in an interview. So this can be a very helpful stream to all of them. There is also a Easy Code Unacademy Telegram channel. So there you get all the notifications about the streams which are going to be live and what all videos are loaded, and even you can like get your query resolved over here. Okay, now comes the main part. So today I will be taking two problems. As I told, like the streams are divided into two parts. This is the first stream. It will take place from 8 to 9 p.m. and the second will start from 9:15 p.m. That's SWIGGY Interview Questions 3. Okay, so in the first stream I will be discussing this problem, unique paths in grid. Like this is a very much like trivial and popular problem, but I personally like this problem because it teaches you a lot of things. Like it involves the basic understanding of a lot of concepts. Okay, and there are some good follow-ups around these questions which I have encountered in my interviews, so I will discuss that as well. Okay. No, Avinash, like as part of 100, that won't give you 100% discount. Okay. Okay. Fine. So let me know if I can start, or if anyone is having any doubt, they can ask, and then I will start off. Okay. Okay, so let's begin. So let me tell you like how I usually take the stream and how the stream goes on. So this is a problem which is asked in interview. So I take up in this manner that, okay, this problem is asked to me and currently I'm giving an interview. So and side by side, beside thinking for the approach and telling you the solution, I also discuss like, okay, how to approach and like how to basically explain your solution to the interviewer. Okay. Sorry Akshay, like I didn't get you. You can check my profile. It will be given in the description of this video. You can check my profile over there. Okay. Okay. And one more thing, like be interactive, because I usually like discuss the solution and even take your approaches as well. So okay, fine. So let's start now. Okay, so the question says there is a robot and it is located at the top left corner of M cross N grid. Okay, mark that start, like the diagram is not there. Let me draw it. Okay, so suppose this is a grid of size like the rows are M and the columns are N. Okay, so this is the M cross N grid. Okay, and you are standing over here on the top left corner. This is the top left corner, that is 0, 0. Okay, you are standing over here, and there is a restriction that robot can only move either down or right at any point in time. Okay, so at any particular point of time you can only go either in this direction or in this direction. Okay, the robot is trying to reach the bottom right corner of the grid. Okay, and how many possible unique paths are there? Okay, so the question wants to say ki we are starting from this topmost left corner and we have to reach the topmost right the bottommost right corner of the grid, and the bottommost right corner is this, that is m-1 comma n-1 if I'm taking a zero based indexing basically. Okay, and we have to tell like how many unique paths are there. Okay, how many possible unique paths are there to reach from this 0, 0 to m-1 n-1. Okay, with a condition that I can only move from a particular cell either downwards or on the right. Okay, or on the right. Cool. So let me give you a small example. So here m is equal to 3. Okay, DFS and backtracking. Yeah, you can think of DFS, but let's like move in a, yeah, like we should just move in a particular way so that we can build up our solution. Okay, I'm taking an approach as well, like yeah, DFS and backtracking is the approach, is the very starting approach we can take up for that. Okay, so first of all, let me explain you a sample example. Okay, so suppose this is m equal to 3, n equal to 2. M equal to 3, my bad, let me just remove this column. MCD, where D is down. C means that combination, permutation and combination wala stuff, right, Rahul? If I'm thinking it right. Actually, this is a very, very good problem. Like, we have only two. Yeah, we have only two coordinates, okay? And we have 2, 3. So we have to go from here to here, basically. And I can go only from this direction and this direction. So over here, okay, MCD into NCR. Okay, even like the formula which we can arrive, I will take on that as well. Okay, so then we can discuss it around. So over here the possible solutions are right, down, down, that is going towards this direction, then down and down, and we have reached this cell, the bottommost right cell. Yeah, common. Okay, and the second path that we can follow is going one step down, and then taking a right. The third possible thing is we go down, we go right, and we again go down. Okay, so there are three possible paths to go from 0, 0 to basically I can say 2, 1. Okay, if I am taking 0 based indexing, correct? First of all, let me know if the question is clear to everyone. Like, I hope it is clear to everyone. Okay, Moa. Okay, now let me think like how can I approach this problem. So I am given a grid. Okay, I am given a grid. Suppose this is some random grid which I am taking just to think. So I am over here and I have to reach over here, and what my condition is कि I can either go down or right, correct? So the first approach that is coming to my mind is why not explore every possible path that, like most of you said, like we can use DFS sort of thing. So DFS is recursion only, so we can use something sort of recursion ki, from a particular cell. Like if I'm standing at a cell I comma j, so from there I can tell like, okay, how many paths are there till this, basically m minus 1 comma n minus 1, if I'm standing at a cell I comma j. Okay, and I have this condition ki I can either go down or right, correct? I have these conditions only. Perfect. Okay, so if I have to say will this be symmetric? Can I say it will be symmetric, that if I go from 0, 0 to m minus 1 comma n minus 1, and if I start from m minus 1 comma n minus 1, and if I go to 0, 0, will all the paths be symmetric? Will there be a symmetry in it? I think so, yes. Like if I just retrace these paths backward, I will reach my possible, like I have already taken all the possible paths from 0, 0 to 2, 1 over here. So I'm saying like if I backtrack these paths, so I can reach to 0, 0, and indirectly it's the same thing, correct? Okay, now there will be one change, I think so. Like if I start from m comma n, okay, there will be a change. Now I have to reach 0 comma 0 if I just like take it in a reverse way. So if I have to reach 0 comma 0, I have to even take care of my direction restriction, correct? So if I am coming from 0 comma 0 to m comma n, then I can move in this direction and this direction. So if I just reverse it, if I just reverse this thing, correct? Kind of what can I say? If I take the mirror image and the mirror image from here, okay, fine. So I can either go here or I can go, okay. So if I move from m comma n, I'm still not sure like whether I will be using DP or how will I approach. I'm just building my approach, okay. Let me see, like if I write the DFS solution or the recursive solution, and if I find like okay there are overlapping sub problems, then I will think, okay, can I memorize and use optimization for, like I can use DP for optimization, okay. Let's try to just say ki this is an interview and like I am just building up my solution from the very basic approach which is hitting my mind currently, okay. Okay, so can I say ki now if I am moving from m comma n to 0 comma 0, तो मेरे को I have to move up or left, just the opposite of it, correct? So can I say if I'm moving in this, if now this is my new direction new direction constraints, so can I say if I am at any cell I comma j, so now I can move to a cell up or right. So moving a cell up means I minus 1 comma j, and moving a cell left means I comma j minus 1, correct? Yeah, so these are my possible directions from a current cell I comma j, okay, fine. And if I go to I, okay, I am starting from I comma j suppose, and I am going over here I comma j minus 1, and on the upside I minus 1 comma j. So I can say कि for this cell also I can move in this direction or this direction. For this cell as well I can move in this direction or this direction, okay. Okay, so can I say कि these are my, like if I am at a particular cell I comma j, so this is my sub problem or the smaller problem, and I say ki solve this problem for me and get me the solution for the solution for the cell above it and to left of it. Can I say ki it boils down something like this? If I am at particular cell I comma j, ki get me the solution from this, get me the solution from this. Suppose I am saying कि the number of ways to reach this cell I minus 1 comma j, and the number of ways to reach this cell I comma j minus 1, let me call it as x and let me call it as y, okay. So can I say कि अगर मेरे को ये दोनों values मिल गई, and that is my bigger problems for this sub problem I comma j, I have to simply do कि since I can reach this cell only either from this cell or this cell, so doing a or sort of thing requires an addition. Like I have to consider both the possibilities. I have to something do addition sort of over. So I can say for this cell x plus y will give me the answer कि okay, to reach this cell, there are x plus y ways. Can I say this? There are x plus y ways to reach I comma j if x is the number of ways to reach I minus 1. Yes, but left and up should be in range. Yeah. Those are corner cases, Rahul. We have to surely take care of them. Okay, we will, like I will take care of it. Correct? Okay. Fine. So this is very clear to me कि मेरा रिकर्शन कुछ ऐसे जाएगा. something like this. My recursion will go something like this, correct? Something from the left, something from the right. Basically this is left and up. This is for the left cell and this is for the up cell, and I have to just add them and return it to this cell. Okay, this will solve my problem, kind of like I will be able to explore all the possible paths, correct? And DFS also does the same thing. If you are a particular node, consider this cell I comma j as a particular node, so we can go only to the nodes who are adjacent to it, right? So we are doing the same thing. Okay, so let me just write a basic 3,2. If I'm at 3,2, then I can go to, if I go to left, then it's 3,1. If I go to right, sorry, up, then it's 2,2, correct? If I'm going over here towards the left, then it's 3,0, and if I'm going towards the up, then it's 2,1. Over here, if I'm going towards the left, then it's 2,1, and if I'm going up, then it's 1,2, correct? Okay, so this is something sort of my, like, मेरा recursion tree कुछ ऐसा चल रहा होगा, correct? Can I say that? Fine. So let me just quickly write down my recursive solution. Okay, I'm just writing a pseudocode. Okay, I hope everyone is familiar. Like, okay, you can just code it down in your particular language if you have got the logic. Okay, so what can I say? I have to return the number of ways, so my return type will be int, and let me just take a solve, and I'm starting from m. This is my size of my grid. Okay, and I have to just return. Now very important thing to take care over here, as Rahul also mentioned, that we should take care about the boundary values, correct? So if I'm starting from the last, can I say for these boundaries, I still have option, I still have both the option, either to go left or to right. Only for this, the top row and the first column, I have to take care of my boundary conditions, right? And basically those will be the conditions that will act as a base condition for my recursion as well. Because why? Because we have definite number of ways to travel if I am in the first row or I am in the first column. That is, I only have one way. If I am in the first column, then I only have a way up, and if I am in the first row, then I only have a way left, correct? So let me just quickly write down my base condition, and my base condition will be if m is equal to 0 or n is equal to 0. That means either I am in the first row, first column, or on the first row. So I will simply return 1, correct? I will simply return a 1. Now I will make my DFS, or I will say recursive calls, and what I will say, get me the result from moving towards left. That is, if I move towards left side, correct? So it will be m minus 1 plus what I am getting when I am moving up, right? Will this recursion serve my solution? Is it clear to everyone? Is this like DFS solution clear to everyone? Okay, so I am assuming that no one is having any doubt. Now let us analyze. Like, there are ways, as I always say, there are ways, particular ways, like either by using recursive tree or master theorem, you can get the time complexity for a recursive solution. But like just to generalize it, or like I could say ki we can think ki whether it is the most optimized or it will fail or give a TLE anywhere around. Okay. So I have drawn this recursive tree. Okay. Over here, I can clearly see I am making redundant calls, that is to 2, 1 and 2, 1. I am surely making a redundant call over here, right? Now, this is like, since the grid is very small, like 3, 2 only. So over here, I can see at max 2 to 3 redundant calls. But if my M and N is very large, then there will be many such cases where I'll be making these redundant recursive calls, correct? Like over here 2, 1, 2, 1. So can I say that there is a possibility that I am making for my n possible ways, like suppose there are n possibilities of going to a cell, so I am kind of like making 2 recursive calls for each of them in worst case. So it will be 2 to the power n. Like I'm just taking a capital N. Don't just like get confused with this size of grid n. Okay, this is some random number which I have taken just to give you an intuition like why it's an exponential time complexity. Correct. Questioning unique paths grid, you can search on Google and you will get it on LeetCode and Interview Bit both. I think so. It's a very, very trivial problem. Okay. So over here, the time complexity for this is exponential. Okay. That means somewhere around in 2 to the power k. Let me just denote it like that. Okay. Now, if suppose my m and n value, that is the value for my grid, is too large, this 2 to the power k would not survive. Like it will hardly survive till 2 to the power 20 or something like that. Okay, then it will give a TLE because you can only do approx 10 to the power 8 computation in 1 second if you are writing your code in C++. Correct. Now let me think if we can optimize over it. If we can optimize. Till here, is everything clear? Is the pace good or slow? Anything, any feedback sort of like which I can just quickly adapt to? Just let me know. Or I will continue. Or okay, now can anyone tell me like what can we do as an optimization over here? We have clearly seen ki, okay, those were our redundant calls. Can anyone tell me how can I optimize it? Memoization. Okay, fine. So basically as Rahul suggested, like we can do memoization. So for the people who don't know about memoization or who are new to these terms, so memoization itself explains like to memorize something. Okay, so what can we memorize over here? Our redundant calls, as we have seen, like 2, 1. Suppose when I first encountered this recursive call at 2, 1, if I would have stored my value somewhere, stored its value, then in the later or in future, if anywhere again I encountered this recursive call of 2, 1, then I will use this value simply because I have stored it, I have memorized it somewhere using some container or anything. Okay, so can I say that then I would be making only one recursive call for each state I am encountering till now? Can I say that? This will solve our purpose. Correct. So let's go for memoization. Let's do memoization. Okay. Now don't just think it's something DP, it will be hard or it's very like difficult. If you have written a recursive solution, DP is nothing. You have to just store your results for the recursive calls. That's it. Okay. Your all the stuff is done if you have already written your recursive solution. Okay. Fine. So now let me do one thing. Since I have to memorize it, so what I need a container where I will be storing my results. Okay, storing my container to store values for my recursive calls. Second, very important thing, whenever you are memorizing, like doing the memorization stuff, the dimension of your container. Okay, like these are very generic stuff, and I can say, like, if you remember all these stuffs and if you go in this way, then surely you can like learn DP, and it will help you a lot in solving other dynamic programming problems as well. Okay. And the third thing, which is very important, is what does your state represent? State of recursive calls. Okay, what does your state of recursive calls represent? Like why I'm writing all these things, like it's in my habit. Like when I started learning DP, so I always used to think about these three things while I am memorizing. If I have got my recursive solution, okay, I know, okay, my recursive solution will handle everything. So then I just always try to figure out these 3 points. Initially just write down and just figure it out later. Like when you have solved quite a few problems on dynamic programming, then you can just skip all these things and you can directly know, okay, you require that. Okay, fine. So this is very clear. Dimension. There is a very important, like very good way to identify the dimension for a container to store the values. Okay, in memorization, you just see in your recursive calls, you just see how many parameters are changing. How many? I won't say parameter, I would say arguments. Okay, how many arguments are changing? Let's quickly jump to our recursive call. I have written over here. Okay, so tell me how many parameters are changing over here, arguments in my recursive calls. How many arguments are there? That will be basically the size of my the dimension for my container. I and j, kind of like m and n, correct? So there are two arguments which are changing on every recursive call, right? Two parameters. So can I say the dimension for my container, the dimension for my container will be a 2D. It will be a 2D vector array, whatever you want to say. Okay, or in general terms, a matrix. Correct. So this satisfies our second point. Now coming to the third, very important. What does your state of recursive calls represent? That means, suppose if I am taken a matrix DP, which is a 2D matrix, so what TP of I comma j represent? So what it will represent? It will represent how many unique paths. How many unique paths are there from m comma n to I comma j. This will be the state of my, and it will give you a very good intuition. Like if you always keep these things in mind, what does the state of your recursive call or your DP is representing. Okay, fine. So it's very clear that I have to take 2D, and the dimension will be at max these I com or ij value at max. What can be the range of those? They can go from 0 to m and 0 to n, right? These are their ranges. तो जितना रेंज होगा मेरे को उतनी ही कैपेसिटी का कंटेनर लेना होगा, करेक्ट? So I will declare a 2D vector. This is the way to declare a 2D vector in what should I say, in C++. Yeah, okay. I will declare my size m, then n, and initially I will say ki what all, like, to reach every cell there is 0 way. Okay, I will just initialize those as 0, or I would say let's not take 0 and let's take -1. Why take -1? Because -1 will tell me ki whether I have reached this kind of indicator, sort of, ki whether I have reached dp of I comma j earlier before, like have I already encountered this recursive call. Cool, fine. So now I will call my function solve, which will be solving my stuff, and I would be passing these values m comma n. Let me just pass it as m-1 comma n-1, okay, because I'm taking 0 based indexing. Let me just quickly write this down. There is a very good follow-up to this question which I have encountered in one of my interviews. I will also share that. So if anyone who has got okay, now this problem will be solved like this, so just don't, oh man, what has happened to the pen? Just give me a minute. Yeah, so m-1 n-1, and I will be passing this vector dp. Okay, so to pass this you have to again write this whole thing. I'm just writing dp over here, correct? And that would suffice. Okay, I have passed a parameter. It's just a pseudocode. Like if you write the same syntax, it will give error over here. Okay, just keep that in mind. You have to pass the 2D vector or the matrix, or in whatever language you are implementing it. Okay, now just I will be using my same recursive functions. Okay, so the base condition was if m is equal to 0 or n is equal to 0, then I can say we just return 1. So I will just store it in my current state, and I will just say ki return 1 by storing it over here. Else I have to just take care ki okay, just let me take a variable as answer, and it will be getting me all the calls for moving towards up plus moving towards left. Okay, just the same recursive call, and I will just simply say ki return this for a particular state m and storing the answer. Okay, and now isn't it the same thing? So that's why I took an indicator of -1. So if suppose I have already come to this state, so this state will be having a non-1 value. So I can check that if I have already come to this state, I will just return the value over here. I won't make this recursive call. Okay, I will skip this recursive calls if I have satisfied this condition that I have already visited this particular DFS state or recursive state. Okay, correct. So now the time complexity will come out to be m comma n for this, because at max we will be visiting all the cells and to find all the unique paths, so we will be covering these much of states. Okay, m comma n. And the space complexity, we have to even compromise on the space over here, correct? So it will be also m comma n, because I have declared this 2D dp for memorization. Let me know if this solution is clear to everyone. Like this is that solution which is very trivial and comes to most of the people mind. Okay, we can think of even something like that which Rahul, or I don't remember, Manish was saying. I think so Rahul was saying about that combinatorics way, correct? Just write a yes or a no if till here everything is fine and you have understood all the stuff. And like despite understanding, because many of you would have already solved this problem, so you got to know like how to approach a problem in an interview. Yeah, yeah, Rahul, first. Like function calls text space. Yeah, right. I got your point. Correct. So Rahul, like you are absolutely correct. Basically, what happens is like your space complexity is considered m comma n, but always when you are going for like bottom to top approach, okay, bottom to top approach, that is memorization approach, okay, whenever you are going for a memorization approach. So that's a very true thing, and that's a very good question, that we should consider the like the stack call space or not. So that's considered, okay. That's why it's always good that if it's possible, like if there is no constraint on like this much memory you can use or something like that, you can go for your memorization. But if not, then you can go for top down approach, and that basically involves tabulation, okay. Tabulation. Shall I explain the tabulation way as well for this question? Like this was the memorization, how can I reduce? There is another way, top down approach for DP, and that is tabulation. Rahul, if you say, I can take the tabulation approach as well. Tabulation is nothing. What we do is, I declared the DP, right? I declared the DP. I will not make any recursive call. I will just fill up my base conditions. Okay, my base conditions will be if I am in my first row. Okay, if I am in my first row, so I will be going from 0 to n, and I will say I will put for my first row every value as 1, because there is only one way, and similarly for my column as well. Okay, and then what I will do, I will do my main thing. So even for tabulation, the way you have written your recursion is like the solution for you. Okay, so I will go from I equal to 1 to m minus 1, for j equal to 1 to n minus 1, and I will say for dp of ij will be equal to dp of I minus 1j plus dp of I j minus 1. Okay, and I will simply return or print whatever you want to do, dp m minus 1 n minus 1. Okay, so this is my tabulation approach, and it will save my recursive stack space. Okay, so it's always good like if you go for tabulation approach, but yeah, you can always go for memorization as well, because it's just like you have written your recursive solution, you have to just add a cache to it. Correct? I hope you got your answer, Rahul. You should always consider that space as well. That's a very important point and a very good point. Okay, okay, so can I continue now? Let's continue with this problem only. There is like basically two more aspects to this problem which we can discuss, kind of follow up. Okay, that was asked to me. Okay, Akshay, fine. So for the tabulation approach, let me just quickly draw this one. Okay, this was our 3, 2. Okay, 3, 2 grid, and what I said कि पहला row or पहला column will be 1, because there is only one way, so I will fill 1 1. Okay, now for this cell, coming to this cell, if I am coming to this cell, this is the tabulation approach. I have already created a table that is a 2D matrix, and now I'm filling the cells in it. Okay, without making any recursive. I'm like only using my iterative ways or using loops for it. Okay, so to come to this this cell, can I say the number of ways I have got to this cell and to this cell is my answer. So till here there are two ways to reach. For this cell, I can either come from here or either come from here. So if I simply add them, so 3. So there are total 3 ways, and I'm returning this cell value. Is this clear now, Akshay? Like I'm just doing the same thing, but I'm not using any recursive call. I am using the iterative way to do it, and that saves my like the memory used for function calls, that is the stack calls for function. Okay, fine. Okay, cool. There is a very two important follow-ups for this question which were asked to me. Okay, as I told, the first one was, can we formalize this? Formalize. Okay, can we formalize, or I don't know what it's a correct word or not, but can we create a formula for it? Okay, and that's a very like when I personally solved it and I tried to create a formula out of it, that was very beautiful approach. Okay, now if I'm going from 0,0 to m,n, okay, and what I have in like what steps I can take, I can either go left or I can go or no, I'm going from 0,0 to m,n. So I have these conditions. I can either go right or I can go down. Correct? These were my conditions. These are my traveling conditions. So can I say that I should have, like if I form, like for 3,2 there was right down down, correct? There was right down down, there was down right down, okay, there was down down right, correct? There was these possible basically strings which were there. Okay, so can I say key the total value, like this total which I am getting as a string for moving right or down, for any case I have to travel all n columns. Like since I am going from 0,0 to m,n, so I am going from here to here, something like that. So obviously I have to cover every column, right? I'll be reaching every column once. And if I have to go down as well, because I have to reach down as well, so I will be having m rows, right? Okay, I have to travel m rows and n columns for sure. I have to go over here. And if you just add it this as well, since I am going from 0,0 to m-1, n-1, so this will be 2,1, and if I add it, 2 plus 1 equal to 3. So if you can see over here, the length of my string is same. Okay, my length of my this string which is giving me the answer, okay, or the path, is same. Till here it is clear. This is a very important observation over here to formalize it. Just let me know if anyone is having doubt over here, because after that it will be kind of solution only. Down jumps and n-1 right jumps, so we have to choose -1. Okay, let me see. N plus m-2 c m minus, okay, you have done that. C m-1, m-1 down jumps and n-1 right, so we can choose, yeah, correct route, correct, yeah. So just take it, like let us forget all this grid theory which was there, ki I have to move in this direction and there is a grid and everything. Okay, now I will take this problem as ki how many ways are there create a string of length m plus n, okay, of length m plus 1 having m r's and n d's. Okay, can I say this question will boil down to somewhere like this? जहां तक अभी हम पहुंचे हैं उसके बाद कैन आई बॉयल डाउन माई क्वेश्चन टू दिस? क्योंकि अब आई हैव टू ओनली फॉर्म स्ट्रिंग्स ऑफ लेंथ m plus 1 that is having a combination of r and d because those are only my paths exactly. Okay, can I say that? Okay, fine. So I'm assuming that boiling down to this statement is clear to everyone. Okay, fine. So now tell me one thing, कि if I am having r red balls, okay, and b blue balls, and we have total, like you might have got the solution and reached the approach, but I'm still telling you कि if you explain in this manner to an interviewer, he will be highly impressed. Like your thought, can you see that my thought process is very much clear over here कि how I have come down to this problem, okay, and how I'm approaching it to formalize it. Got it? These things are like the key things which you have to keep in mind. Now can I say कि I am having r red balls, b blue balls, and total balls are r plus b. Now if I have to choose red balls, okay, my thing is it should have r red balls and b blue balls, okay, and the total things are this. Can I say कि if I have chosen r red balls, if I have chosen this, so can I say I have automatically chosen this b blue balls as well, right? If I have 4 same colored stuff and 4 the other colored stuff, so if I have chosen one stuff, then I've already chosen the other one. We don't have to take care of that. It's kind of like if I try to explain in terms of philosophy, so I can say कि if you have chosen the truth, so you have already chosen like this the false part as well. Okay, fine. So I can say कि I am having m plus n length string, and if I choose m r's, then I have already chosen the remaining what I can say n d's. Okay, so can I say this is the number of ways to reach a grid starting from 0, 0 to m, n. So kind of this is my answer, m plus, and the formula for NCR, okay, n choose r is n factorial by r factorial into n minus r factorial, correct? Right? So can I write this as m plus n factorial by m factorial into m plus n minus m, that is n factorial. Okay, so this is the formalized version of this, right? Is this approach clear to everyone, how I came up to this formula? That was very intuitive and very basic combinatoric stuff. Fine, let me quickly again give you a follow-up for this, which was asked to me, like this was also asked to formalize it, and one more thing was asked in one of my interviews, that was if you were having obstacles in your grid, okay, if you are having obstacles in your grid. That means you are given a grid, okay, you are given a m cross n grid, and it is having binary values 0 and 1. 1 represent there is an obstacle, and 0 represent you can go to that cell, okay, you can go to the cell I comma j, okay. So suppose I fill 0 1 0 0 0 1 0 1 0 0 1 0 0 1 0 0 and 0, okay. So for this follow-up question, पहले तो हमें यही चेक करना होगा कि is my starting or the destination where I have to reach is 1 or not, because if it's 1 then it's an obstacle, मैं वहाँ पहुँच ही नहीं सकता. So simply the answer will be 0, or like there are no ways, correct. We will be using the same approach. What we used for our previous solution, okay. dp I comma j was dp of I minus 1 comma j plus dp of I comma j minus 1, okay. This was our basic, like our main core recursion for what we have written. So now we have to just check one condition, if my matrix at I comma j is equal to 1, that means to reach this state I comma 0, how many possible ways are there? Zero ways. यहाँ तक आने के 0 ways है, because I can't reach it, or else I will just do the same thing which I was doing. J equal to dp of I minus 1 j plus dp of I j minus 1. That's the very, very basic thing, and this is only which we have to add in our solution, okay. This thing we have to add in our solution, just this thing, okay. So this is one of the good follow-up, like if you are having obstacles in grid. Did you all get it? Okay, and there is one more follow-up which I have encountered for this problem. You can think of it, okay. That is, if I comma j cell is having some weights, okay, is having some weights, kind of like this problem only, and the condition say okay, you can go either towards right or down. So minimum weight path, what is the minimum weight of that path, or the path which is having a minimum weight to go from 0 comma 0 to m comma n, okay. This is also one of the good follow-up for this problem which you can think of, okay. Okay, fine. So this was it, like for the first question or the first stream. Let me know if everything was clear, and if you are having any doubt you can ask. Anything in general as well you can ask about interviews and all. And the next stream will be starting at 9:15, okay. The second question I will be discussing over there. Till here, in this stream, if anyone is having any doubt or any questions, just let me know. Yeah, Rahul, like whenever you are in interviews, so always try to think out loud. That's the very first most point, because interviewer, no, always try to give tell your thought process to the interviewer, because that would even help the interviewer know. Akshay, like I have currently joined Unacademy as an educator. Rahul, I'm coming to my point. Just give me a minute, okay? So I don't have currently courses, so I have started off with interview cracking series. Over here, I like discuss interview problems and do live problem solving as I have done today, okay? But if you have doubt in any topic or any sort of thing, you can like contact me on LinkedIn as well. We can have a discussion. Yeah, Rahul, coming to your question, that always think out loud in an interview, because it will help the interviewer know how you are building up your solution first. Secondly, sometimes we don't think in the right way. Okay, so that will help the interviewer to give us hint and to lead us in the right direction. So for both of the things, it's very important to always think out loud. Okay. I hope you got your answers, Rahul and Akshay both. Yeah, sure, definitely, Akshay. Okay, so guys, like meet you in the next stream. Join it. It will be at 9:15, and do share it as well with your friends and colleagues. Okay. I really enjoyed this discussion with all of you. Okay, fine. And do like, share, and subscribe to the channel as well. Okay, fine. Okay, guys. So meet you in the next stream, which I will be starting at 9:15. See you all there.